Hello. Today we're going to be talking about arithmetic sequences. And a sequence, first of all, is a set of numbers that are arranged in a specific order, usually from least to greatest or greatest to least. So if each term in the sequence increases by the same amount, or the increase is constant, the sequence is considered to be an arithmetic sequence, and the increase is the common difference. So let's determine whether these sequences are arithmetic. So my first sequence has the numbers in order 1, 6, 11, 16, and 21. And the increase from 1 to 6, we go up by 5. The increase from 6 to 11, we go up by 5. From 11 to 16, we go up by 5. From 16 to 21, we go up by 5. So, is the sequence arithmetic? Yes. The common difference? Is 5. In the next sequence, the numbers go in order 2, 5, 9, 14, and 20. So let's see if this is arithmetic. From 2 to 5, we increase by 3. From 5 to 9, we increase by 4. 9 to 14, we increase by 5. And 14 to 20, we increase by 6. So no, this one is not arithmetic. There is no common difference. Let's try something else, a different representation of these. I have another sequence for us, and this time we're asked to graph it. So we have the sequence 0.5, 2, 3.5, 5, 6.5, and 8. And so what we're looking at here, our first term, so I'll call it a sub 1, is 0.5. Our second term, a sub 2, is 2. A sub 3 is 3.5. A sub 4 is 5. A sub 5 is 6.5. And we're given a sub 6 as well, which is 8. So we essentially have 6 ordered pairs here. My first ordered pair will be 1, 0.5. My second ordered pair, 2, 2. Then 3, 3.5. And so on. So there's 4, 5, 6.5, and 6, 8. So to put them on the coordinate plane, 1, 0.5 goes there. Here's 2, 2, 3, 3.5, 4, 5, 5, 6.5, and 6, 8 is going to be up here. And so you can see we're not going to connect them with the line because there's nothing in between to indicate that there's numbers in between these ordered pairs, but it should make a linear relationship. And if something has a linear relationship, we should be able to write a model for it. So let's say I want to find the a sub nth term, or the nth term for this sequence. I know the first 6, how do I find the nth? Well, think about what's happening here. We're starting at 0.5, that's my starting location. And we are repeatedly adding on, well, our common difference here, each time we go up, is 1.5. So each time we do this, we're adding on 1.5. That's my common difference. So I'm going up by 1.5 units per term. So as I go to the next term, I'm going up by 1.5. So it's 1.5 per term for n number of terms. But if we think about what we've written here, again, it's a linear relationship, so we would be looking at something that would consider this to be the y-intercept and this to be the slope. And while our slope is constant, the y-intercept here isn't actually 0.5. That's when n is 1. So how do we adjust this? Well, instead of taking it times n, we want to move this back by 1 unit. So we put in n minus 1 there. So we would adjust this here. A sub n is equal to 0.5 plus 1.5n minus 1.5. And then we could simplify by combining like terms. So 1.5n minus 1. And if you think about what's happening here, if we were to continue this, if we were to go down 1.5 units and over 1 unit, we would be sitting at a y-intercept of -1. So this is not our y-intercept, this is our y-intercept. So let's take a further look at this. We want to write an arithmetic sequence for this set of numbers, 8, 11, 14, 17. So my first term is 8, my second term is 11, my third term is 14, my fourth term is 17. Well, my common difference here, to keep going up each time, we're going to add 3. We add 3 to 8 to get 11, add 3 to 11 to get 14, add 3 to 14 to get 17. So my slope is 3. That's my rate of change, my common amount or common difference. So where do we start though? Like what would be our y-intercept? Well, if our first term we have 1 comma 8, why don't we think about this if we go backwards by 3? We had our first term of 8, and there's our second term of 11. What's our 0th term? Well, really it's what did we add 3 to get 8? And that number would be 5. So our y-intercept must be 5. So to write our arithmetic sequence for this, the nth term would be 3 times however many terms we've had plus 5. So you can test this out. If I wanted to find a sub 4, we would do 3 times 4 plus 5. So this is asking me what's my fourth term? Well, that's 12 plus 5. And a sub 4 would be 17. And you can see how that's accurate. Well, then if I wanted to find, let's say, a sub 100, my 100th term, well, that would be 3 times 100 plus 5. So a sub 100 would be 305. And we are done.